2 shows a speed time graph for the model of the motion of an athlete running a 200-meter race in 24 seconds. This immediately tells us that the area under the graph is 200. And we're given some information, it's all on the graph, so I'm not actually going to say it all out loud. But then we're asked to find the acceleration of the athlete during the first 4 seconds of the race, stating the units of our answer. Well, they're starting from 0 and they're going up to 10 in 4 seconds. We can actually do this really quickly and just say that it's the change in speed over time, 10 over 4, which becomes 2.5 meters per second squared. If you wanted to, of course, you could bring Suvat out. It's just a little bit unnecessary. U is 0, V is 10, T is 4, and then we've got V equals U plus AT. So A will equal V minus U over T, and we get the same thing, 10 minus 0 over 4. Find the distance covered by the athlete during the first 18 seconds of the race. Okay, so that's going to be this area here. I could split it into, well, I could just have a single trapezium, or I could split it into a triangle and a rectangle. A trapezium will be slightly quicker. I think I'll go for it both ways. So, okay, I've got a height of 10. So half times 10. And then I've got to add my 2 parallel sides. Well, my bottom one is 18. And my top one is going to be 18 minus 4. It's going to be 14. This is 32. Times by 10, 320. Then divide by 2. It's going to be 160 meters. Instead, you did the triangle and the rectangle separately. Then we do 4 times 10 divided by 2. That's going to be 20. And then 14 times 10 is 140, and then add them together. So look, both are effective. And finally, we're asked to find the value of U. So this is going to come into the very last part. This area here is going to equal, let me call it A1, or just, no, let me just call it A. A is going to equal 200, because remember, I said right at the beginning, that was the total area under the graph, minus 160, it's going to be 40. And then I'm definitely going to use the trapezium for this one. I think trying to split it up into a triangle and a rectangle is going to be complicated given that U is there. So it's going to equal a half times 6. Remember, this is a trapezium on its side. We've got the 2 parallel sides here. So half times 6. Then it will be U plus 10. And I can times through by 2 to give me 80, divide through by 6. That means U plus 10 is going to be 80. Actually, I could just do half of 6 and then divide through by 3. So it's going to be 40 over 3. And then U is going to end up being 10 over 3, or 3 1/3 meters per second.